Thank you so much for joining me on this CLEP College Algebra series. We are now in Unit 2, so we're moving right along, and that's excellent. 2.1, we'll be solving linear equations and inequalities. Okay, before we do that, I want to go ahead and introduce to you some of the terminologies, the terms that I'm going to be using. Okay, so linear equations, you might have something that looks like. Okay, you might have something that looks like this. It says solve 2x plus 5 is equal to 1. Okay, so here are some of the things that I'm going to be talking about. First of all, this is an equation. Equations have equal sign. So it has an equal sign, therefore it's an equation. Okay, equations make a statement, so they tell you something that's true. Something is equal to something. Okay, so example 3 is equal to 2 plus 1. That's an example of an equation, a true equation. 2 is equal to 1 plus 1. That is an equation. 2 is equal to 1 plus 1. It makes a statement, and it makes a statement that is true, that should be true. Another kind of equation that you can test is 6 is equal to 2 times 3. That's an equation. Okay? Now, what we're trying to do with solving equations is they give you something you don't know for sure. For example, if you say 6 is equal to 2a, okay? 2 times something equals 6. And your goal in solving an equation is trying to figure out what a is. What times 2 will equal 6? Well, we already see here that 2 times 3 is equal to 6. So a must be 3. So a must be equal to 3. Okay, so that's something that we solve. Okay, for another example is like the one we have previously. What if you have 2 is equal to 1 plus y? Figure out y, figure out what y has to represent so that 1 plus y will actually equal 2. Well, we know that 1 plus 1 is 2, so y must be 1. Okay, so here the point is equal sign tells you how to make a true statement. Equal sign means we have an equation. The reason why I'm pointing this out is because sometimes we might not have an equation. We might have something we call an inequality. But for now, we're going to go ahead and focus on equation and how to solve it. Another thing that we need to figure out is sides. Okay, sometimes I'm going to say left side, right side. I want to be very specific and very clear on what the sides are. Okay, so this equal sign splits your equation into two. Okay, so I'm just going to highlight it. This splits your equation into two. Okay, one side, this is one side, and that's another side. Okay, so equal sign splits into two. So sometimes I might say, look at the left side. Left side, what I mean is on the left side of the equal. Right side, what I mean is on the right side of the equal sign. Okay, so now we learn equal sign represents an equation. Equations have equal signs. Okay, equations make true statements. Okay, equations have sides. You can have a left side. When I say left side, that's the left of the equal to. If I say right side, that is the right of the equal to. Okay, so those are the things that we could be looking for. Okay, so to solve an equation, we solve equations by undoing. Okay, so let's start with the basics. Solving equations. Okay, solving equations. So, example 1. I want you to solve x plus 4 equals 23. What number plus 4 will equal 23? Okay, before you solve an equation, I want you to look at both sides of the equal to. Okay, so here's the equal to is divided into two sides. There's the left side and the right side. Okay, on the left side, I have x plus 4. And on that side, if there's anything you need to combine, if there's anything you need to if there's any way you can simplify each side, do that. Okay, x plus 4. X and 4 don't go together, so it's already simplified. Now let's look at the right side. The right side has 23. 23 is by itself. Nothing else you can do to it. Now let's continue. To solve for a variable, you want to undo. You want to do the opposite. So here you have x plus 4. You want to get rid of a plus 4. To get rid of a plus 4, you want to subtract. So minus 4 here, minus 4. So what I mean is subtract 4 on both sides. Okay, so 4 minus 4 becomes 0. So you cross 0 out because x plus 0 equals x. Anything plus 0 is that same thing. So we don't have to write it. So now you bring down x is equal to 19. X is equal to 19. That means that 19 plus 4 is 23. Okay, so you can always check your answer by plugging in. Replace 19 with x. 19 plus 4. And we see that 19 plus 4 is indeed equal to 23. So that is correct. Okay? Example 2. How do we undo subtraction? Okay, so let's say we have x minus 2 equals 11. Okay, nothing you can do on the left and on the right side. They're already simplified on each side. So I want to get rid of a minus 2. So you want to add 2 to both sides. Okay, so x, negative 2 plus 2 becomes 0 and goes away, equals 13. And that's it. Again, you can check your work. That's 13 minus 2 equal 11. Yes, so you are correct. Alright, how do we undo multiplication? Solve. 3x is equal to 12. What is the opposite of multiplication? The opposite of multiplication is division. So to get x by itself, x is the king, we want to get it by itself, we divide both sides by 3. 3 divided by 3 is 1. 1 times x is x. So when you have 3 divided by 3, you just have an identity. 1 times x is x equals 4. X is equal to 4. You can check your answer. 3 times 4 is 12, so you are correct. Okay, let's go ahead and move on. Okay. So now we are going to undo division. So what if you had x over 5 is equal to 12? Okay, the opposite of dividing by 5 is multiplying by 5. So we can multiply by 5 on both sides. So 5 over 5, 5 on top, 5 on the bottom, becomes 1. 1 times x is x, equals 12 times 5 is 60. Okay, and you can check that. 60 divided by 5 is 12. So this is correct. Alright, so those are simple solving equations. Now I'm going to make it a little more complicated. Okay, so I'm going to move it up one level by introducing parentheses. 2x plus 5 is equal to negative 10. Okay, let's make this negative. Okay, if you have this, again, you want to look on both sides of the equal sign. On this side, it's not completely simplified. So this parentheses is going to restrict you from doing a lot of things. One way you can do this is the way I'm going to teach it is you can distribute. Negative 2 times x is negative 2x. Negative 2 times 5 is negative 10 is equal to negative 10. Okay? Then step 2, look in both sides. Can you simplify any more? On the left, x and a number is not going to go together. So there's nothing you can do on the left. There's nothing you can do on the right. So you go ahead and move on. Okay, so your king right here, what I call my king, is my variable. I'm trying to get x by itself. Okay, my king is my variable. I'm trying to get x by itself. So I want to get rid of everything before I can get x by itself. First, you want to get rid of the minus 10. Okay, it's almost like the opposite of PEMDAS, of your order of operation. I want to get rid of the minus 10. What I would do is I want to add 10 to both sides. Okay, so negative 2x, this crosses out and becomes a 0. 2x plus 0 is negative 2x plus 0 is negative 2x. Okay, and equals these two, negative 10 plus 10 is 0. Okay, instead of just crossing it out, you put 0 here, because if you don't put anything, there's nothing on your right side. So you want to put 0 as the placeholder, and then divide both sides by 2, negative 2. So your variable equals 0. So x has to be equal to 0 for this to equal negative 10. Okay, if we wanted to plug it back into the original, we can. Negative 2, we got a 0, plus 5. Is that going to give you negative 10? I'm going to put negative 10. Is that going to give you negative 10? Question mark. Okay, well, 0 plus 5, according to our order of operation, is 5. And then multiply, that gives me 10, negative 10. So yes, this is my correct answer. Okay, so your x is 0 is the correct answer. Alright, let me not confuse you with the real answer. The real answer is x equals 0. So I distributed, and then I added 10 to both sides, and then divided by 2 to get x by itself. Okay, so what if you could have also, some people might actually also do this problem another way. Negative 2x plus 5 is equal to negative 10. They could undo this negative 2. It's being multiplied to the parentheses, so they could also divide by negative 2 on both sides. So x plus 5 equals 5. Subtract 5. X equals 0. As you can see, either way you will still get the correct answer. Okay, so it depends on what you're comfortable with and how good you are on things like this. Okay, so what if we had variables on both sides? 2x plus 3 plus x is equal to 5x plus 18. Okay, so again, here is my variable. Okay, so here's my variable. Here's my equal sign. Equal sign makes a true statement. Okay. Now look on both sides. If you look on the left side, try to condense it, try to simplify it as much as you can. So without even solving it, I'm looking on the left side. Notice how I can combine on this side. I can combine this to be 3x. All you're doing is you're organizing, you're putting together, you're combining like terms on each side. You're not doing anything to both sides, so you don't have to worry about undoing yet. Plus 3 is equal to 5x plus 18. Okay, that's step 1. Look on each side. If there's anything that you need to simplify or combine, go ahead and do it. If you have something in front of the parentheses that you need to distribute, you can go ahead and do that. Okay, now I notice that, whoa, I have a variable here and a variable here. So what I need to do is I want to get all the variables on one side, and I want to get all the constants on the other side. Okay, so doesn't matter where you want the variable. You can always have it on the left, or you can do it wherever you like. So I want to get all my variables on one side. So let's try to get all the variables on the left. Well, I want to get rid of the 5x from the lot 9. To get rid of a positive 5x, I have to subtract it. To completely get rid of it, I have to subtract it to make it 0. Okay, if I subtract this on this side, I will subtract it on this side. Okay, so on one side of the equal to, on the right, and then on the left. Okay, notice how I went ahead and aligned it with the x's. Okay, because x's will go together. 3x minus 5 is negative 2x. I will bring down my positive 3 equals, this goes away, so I have 18. I want to get my numbers on the other side, on the right side. So let's get rid of plus 3 completely. Get rid of it completely means make it 0. Subtract it on both sides to completely get rid of it. You don't want to see it on that side. 3 minus 3 is 0. So bring down the negative 2x equals 15. Okay, and then finally, now that I've kind of put all the x's on one side, all the numbers on the other side, now I want to get the x alone. I just want to have one x. To do that, I want to divide the negative 2. Whatever you do to one side, you want to do to the other side. So your variable x is equal to 15 over 2 negative. Okay, it doesn't matter where the negative is. The negative makes the whole number negative. Okay, so I will have you go ahead and check that on your own to see if that is truly the correct answer. Okay, so I'm telling you that it's correct. Go ahead and prove it for yourself. Okay, now let's do something a little bit more challenging. Okay, so let's say we had x plus 5 minus 3x all divided by 3 is equal to 7. Okay, so you want to do this problem, but you're looking at it and you're like, oh my god, what am I going to do? As you can see, what makes this problem complicated? And your answer is probably like, what's with the divided everything by 3? Well, it's easy to get rid of divided everything by 3 because all you have to do is multiply it out. If you multiply this by 3, whatever you do to one side, you have to do to the other side. Okay, remember your side is divided by equal to. The equal sign divides your equation. So look, 3 divided by 3 becomes 1. Anything times 1 is itself. So that goes away and eliminates that denominator. And now your problem looks a lot more simple. X plus 5 minus 3x. Minus 3x equals 7 times 3 is 21. Okay, now on the left side, you notice that you have like terms. So you want to combine that to 1. So this is negative 2x plus 5 is equal to 21. Okay, and now you want to subtract 5 on both sides to get it all on one side, to get all your constants on one side. Subtract 5 on both sides. Okay, so now you have negative 2x. This goes away. Negative 2x becomes 0, disappears, is equal to 21 minus 5, and I believe that is 16. Okay, now you divide both sides by negative 2, divided by negative 2, so your variable x is equal to negative 8. Okay, so your variable is equal to negative 8. Alright, one more and then we can move on. What if we have fractions? So let's say we have 2/3 x is equal to 12. Let's make that 10. Okay, how do we get rid of fraction? Okay, well, 2/3 x. We can do this in 2 steps or we can do this in 1 step. And I'm going to teach you how to do this in 1 step. Okay, so 1 times x will give you x. So you want to get 1 times x, right? Well, if you multiply this by the reciprocal, which is like saying divide by 2/3, so division is the same thing as multiplying. If you multiply by the reciprocal, 3 over 2, notice 3 on top, 3 on the bottom cancels out and becomes 1. 2 on top, 2 on the bottom cancels out and becomes 1. 1 times x is x is equal to, now we just have 10 over 1 times 3 over 2, which is 30 over 2, which equals 15. So the moral to the story is, if you have a fraction, you want to flip and multiply, which is the definition of division. Division is flip and multiply. Okay? So that's that. Now let's talk about inequalities, how they relate and how they don't relate. Okay? What is an inequality sign? Inequalities Inequalities are just these symbols. Okay, you've seen this in lower level math. This symbol represents less than. Okay, this represents greater than. Okay, this with a tick mark represents less than or. Okay, equal to, less than or equal to. Okay, so it could either be the less than or it could be equal to. And this represents greater than or equal. Okay, so let's look at some examples that would make sense to the average person. Okay, let's say I want a number that is greater than 12. Give me a list of numbers that are greater than 12. Okay, numbers greater than 12. Okay, well, 13 is, 14 is, 101.3 is greater than 12. Here's a question. Is 12 greater than 12? The answer is no. 12 is not greater than 12. Okay, well, let's change this problem a little and I'll ask you for numbers that are greater than or equal to 12. Okay, these numbers are certainly greater than 12. We just said it. They were 13, 14, 101.3. 0.3. Okay, but now 12 is also greater than or equal to 12 because 12 is equal to 12. Okay, well, let's make a list of what it's not. 11 is not greater than 12. 11 is not greater than or equal to 12. Okay, at least let's have one. Okay, now let's talk about less than. Okay, numbers that are less than 12. Numbers that are less than 12. 0.001 is less than 12. Negative 12 is less than 12. Okay? 11 is less than 12. 13 is not less than 12. Okay? 12 is not less than 12. 12 is not less than 12. Now, how about numbers that are less than or equal to 12? Okay, numbers that are less than or equal to 12. Okay, so again, this was 001. 0.001, 11, negative 12. Okay, negative 12. 13 is not less than 12. Okay, but now 12 is included. 12 is less than or equal to 12. Therefore, 12 is less than or equal to 12. Okay. Okay, so now we're on part B. So congratulations, we're now on part B. And we're going to focus on linear inequality. Okay. First of all, how do inequalities and equations differ? We looked at something like this. Equal 3. Okay. Equations have equal sign. Inequalities do not have equal sign. Inequalities have inequality sign. So, for example, 2x minus 1 equals 3. 2x minus 1 is less than 3. Less than 3, that's an inequality sign. That is an inequality. Okay, so that's one of the ways they differ. Okay, another way they differ is by their solutions. For example, if you have x equals 1, the solution is just one thing. The solution is x equals 1. And if you looked at a number line, here's 0, here's 1. You only have one solution at 1. Okay, so your solution is right here at x equals 1. Okay, as opposed to if you had an inequality, let's say x is greater than 3, well, the solution here is all the numbers that are bigger than 3. Okay, and it turns out that here's 0, let's say this is 3, is everything that's bigger than 3. Okay, so you can draw it like this. So 3 is not included in the solution of this. Okay, so let's talk about all the different inequalities and how they look. We're going to use numerical examples. So let's say you had x is greater than 1, while the solution is going to be start at 1, 1 is not included, everything greater than 1. Okay, let's say you had x is less than 1. Okay, again, you start at 1, but now your solution is not including 1, and it's everything less than 1. Okay, well, what if you have that lovely tick mark that represents equal to? Okay, how does that make your problem different? How does that make your solution different? Well, x is greater than or equal to 1 still starts at 1, but now 1 is included. So if 1 is included, you're going to need to fill in that hole. Okay, so this makes it included. So you have to fill in the dot. Notice how this is an empty dot. This is now a dot that is filled in. And that's how you show that 1 is included. Same thing for less than. So x is less than or equal to 1. Okay, you make a hole at 1 that is filled in. Okay, so something like this, and then you draw an arrow or you shade to show less than. Okay, so how do they differ? One, they differ in their solution. Okay, that's my shortcut for solution. Okay, another way to differ is they differ in the way you solve them. Okay, so when you multiply or divide a negative number across, I don't know what's going on, inequalities, okay, you want to change the inequality sign. Okay, I'm having a little bit of computer issues. Okay, so when you multiply or divide a negative number across inequalities, change the inequality sign. Okay, so that makes a difference. For example, if you had negative 2x plus 3 is greater than or equal to 5. Okay, so you will subtract 3 on both sides, just like you will if you had linear equations. Okay, subtract 3 on both sides, and you have negative 2x is greater than or equal to 2. Now you're dividing by negative 2. Whenever you divide by a cross inequality sign by a negative, you want to change the sign, inequality sign now, so your variable is now all the numbers that are less than negative 1. Again, if you divide across inequalities by a negative, you flip your inequality sign. Okay, so now we are no longer dealing with inequalities. We're no longer dealing with greater than, we're now dealing with less than. Okay, so how about if you had x plus 1 divided by negative 3 is less than 2. Alright, so I want to get rid of this divide by negative 3, so I'm going to multiply by negative 3 on both sides. Because I multiplied by negative 3 on both sides of the inequality, Okay, because I multiplied, this automatically changes. So we have negative 6 here, and we have x plus 1. And then subtract 1 on both sides. So now you get x is greater than negative 7. Okay, so that is how they differ in solving them. The only difference in solving equations and inequalities are when you're dividing or multiplying by negative numbers. Okay, subtraction and addition doesn't affect it. It's dividing or multiplying by a negative number. Okay, so now let's do a few examples. Okay, we're gonna do some mixed examples. So let's see. Example 1. I want you to solve m plus 3 is greater than negative 4. Okay, let's make that 2m. Subtract 3 on both sides. To get rid of plus 3, you do the opposite of addition, which is subtraction, to make this a 0. So this is 2m is greater than negative 7. Divide by 2. Okay, although this is a negative 7, that's not what is being divided across inequality sign. Okay, you're dividing by a positive, so it does not change the inequality sign. So m is all the numbers that are greater than or equal to all the numbers that are greater than or equal to 7 over 2. Final answer. Okay, and if you were to graph this, you would go to, if this was 0, this is 0, this is negative 7 over 2, this is not included, 7 over 2 is not included in your answer, and it's everything less than 7 over 2.